Okay, so let's see. A 6 kilogram block rests on a level counter where the static coefficient is 0.62 and the dynamic is 0.310. Calculate the dynamic and maximum static friction between the block and the counter. Store these in your calculator, right? And heaven help you if you mess these up, right? Because you're going to use these numbers to check them and double check them. You're going to use these numbers in the whole rest of the assessment. If you mess them up, I'm not going to go through and figure out what you would have gotten if you had gotten the right number. Okay? So we'll just figure this out, right? Our force of friction dynamic is always equal to just mu times the reaction force, which is mu times m times g. And that's because gravity is going to pull down on this thing, right? And the surface will push up, and these things are equal to each other. It's just mg. Okay? So that equals, what is it, 0.31 times 6. It's supposed to be a decimal point there, times 9.81. And this is newtons per kilogram. This is kilograms. And this has no units. It's just a coefficient. They tend not to have units. So 0.31 times 6 times 9.81. I'm going to store that bad boy in alpha A. 18.2466. Use when you do all the rest of these problems, use that number, or at least use 18.25. Okay, don't round it to just 18.2. Okay, so yeah, we got that number right. And then our maximum static friction, this is our maximum value, right, is equal to mu times R, and this is the dynamic times R, this would be the static times R, which is the mu static times M times G. This would be dynamic, right? So that is 0.610 times 6.00, and that's kilograms, times 9.81 newtons per kilogram. Okay, so 0.62 times 6 times 9.81, 36.4932. Okay, so that's the biggest the force could be on this exerted to the side before it would break free. Forces bigger than that will make it break free and slide. Forces less than that it will laugh at and say, "Ha, you can't make me slide." Okay.